All right, today we are going to look at air pressure a little bit more in detail. So, what is air pressure? Well, or what causes air pressure? Three factors cause it, and my hint is these three pictures. Well, to change. What causes them to change? Well, first off, temperature. Temperature definitely causes air pressure to change. And then you have the moisture content. That causes air pressure to change. Finally, last but not least, your altitude, how high up you are from sea level. I kind of talked about that yesterday. So let's look at temperature. Well, as air temperature increases, the air molecules move farther apart. They get farther apart, which makes the air pressure decrease. So, like, they're not as close, they're not pushing in on you, and they're farther and farther apart, which decreases. And if you look at this, my little diagram, you see that it's an indirect relationship. As the air pressure goes up, or as air pressure goes up, and well, sorry, I'm saying this wrong. As temperature goes up, air pressure goes down. As pressure goes up, temperature goes down. So it's the opposite thing that the other one's doing. Let me move this. The air pressure decreases because there's the same amount of air taking up more space, making it more dense. So as the temperature is going up, the pressure is going down because it is more dense, it's more compact, it's more moving together. All right? The next thing we're going to look at is water vapor. So moisture. As humidity increases, lighter water molecules replace the heavier nitrogen, carbon dioxide, oxygen molecules. And I know it says H2O, but H2O is a little bit less heavy than those other molecules, making it less dense, exerting less pressure. So you can see right here, dry air. You got some of these red, which you could say maybe they are nitrogen. And as water evaporates, it starts to replace some of the I want to say those are maybe hydrogens, or sorry, oxygens, which oxygens are definitely more heavy than hydrogens. So that's starting to replace. And then as air gets humid, you notice there are no red dots over here. There's less orange or yellow. So it's less dense. It doesn't weigh as much. And you can see the difference between the two weight-wise. So again, it's an indirect relationship. As the water vapor increases, pressure decreases. As pressure increases, water vapor typically is decreasing. So whatever one is doing, the other one is doing the opposite. Again, last but not least, we have altitude. So altitude increases. There's less atmosphere above you. Remember how I said this yesterday? And therefore, there's less pressure. There's less stuff pushing on you. Basically, the air above you is less dense than the air below you. So if you're like wicked tall, which I am not, you could be feeling different pressures from your head to your feet. Although, granted, you would have to be 50 feet tall to feel this. The same thing goes with this as it goes with the other two. It is an indirect relationship. So as altitude increases, pressure decreases. As altitude decreases, pressure increases. The closer you get to the surface, to the center of the earth, the more pressure. Pardon me. Now, less dense air, less pressure it exerts on you. And it does say page 14. We looked at this before. I want to make sure I get it in. Right here, you can see pressure decreases as you go up in altitude. So if you're confused, if you don't remember that, this tells you right here. Okay? All right. So we're going to look at another map, and you're like, oh, I know what this is. Well, we've already seen contour lines. We've seen isotherms. So contour lines tell you the elevation. Isotherms tell you the temperature. Now we're going to look at something called isobars, which are isobars are lines that connect points of equal air pressure. So contour lines connect equal heights, equal elevations. Isotherms connect equal temperatures, thermometer. So isobars, think of like millibars, that gives you equal pressures. Now, if you look at this map and you look at these lines, you'll notice that these lines typically are 4 millibar intervals. So let's see. Okay, so this is 108, not 108, 1008, and this is 1004. There's a difference of 4 in between them. And then there's 1008 again, and then 12, and then 16. And if you notice this low, we'll get into this a little bit later, but I wanted to make this connection now. This low, look at that pressure, 996 compared to the high, which is 1019. I know the high is kind of cut off, but there's a high up here also. You can just see the bottom of the H. It's 1037. So that's high pressure. That means it's exerting a lot of pressure on you, where low pressure is not so much. Okay, so here's the big thing about pressure. We've already just converted from, millimeters to millibars. Now we're going to take it a step further with the millibars. On weather maps, barometric pressure is represented by 3 digits. But you just saw there's more than 3 digits here. And it's located in the upper right-hand corner of a circle. This circle represents a city on the weather map as part of a structure called a station model. So right here, you can see I've got my circle and I've got my 3-digit number. This is my pressure. So rules to follow to find the value, what that actually represents. Number 1, you're going to remove the decimal point between the last 2 digits on the right. So if I had a normal number, say I had, I'm going to scroll up, 1018, and I'll leave it at that. Well, what I would do is I would remove the decimal point between the last 2 numbers. So it'd be technically 1018.0. So remember when we were looking at it, it had the point something. So 1018.0. I'd remove the point. Then the number 9 or 10 in the front is removed. So 1018.0, get that 0 out, so it'd be 10,180. I'd get rid of the 10, and I'm left with 180. Okay, so what this is saying, if I was going the reverse, if the original number is above 500, a 9 would get placed in front of it. If I'm taking these 3 numbers. If the original number is below 500, I'm giving it a 10 in front and putting a decimal in between. I'm going to get to this in a second. This is not exactly the best description of what to do, but we're getting there. So first things first, we are going to encode or convert to the 3-digit code. That's encoding. So what I'm going to do is I'm going to take this decimal place. I'm going to get rid of it. It's going to not exist. And then I'm going to take either the 9 or the 10 in the front and get rid of it. So this first one, if I get rid of that dot, get rid of the 10, I'm left with 030. Let's look at the next one. I've got 1008.2. Get rid of this dot, get rid of the 10, and I'm left with 082. That's your 3-digit code. Let's look at this next one. 968.5. 4. So there's no 10. So I'm getting rid of this 9, and then I'm getting rid of the dot. So I'm left with 684. So really, you're only writing down the last 3 numbers. So if I get rid of this, it's 216. I ignore any decimal place point in this. So the last 3 numbers, 720, 618. Ooh, there's no decimal. What am I going to do? Well, remember in math, decimal is just like it's a placeholder. You know there's a decimal there because if you were to subtract, say, I don't know, if 720 or 72.5, you would need a decimal place. You know there's intrinsically, there is a decimal place right there. So all you have to do is get rid of the 9 and remember that there is an imaginary 0 there. So remember that placeholder. So it's going to be 810. All right, take the last 3 numbers, ignore this decimal, 681. Last 3 numbers, ignore the decimal, 320. And the last one, if that ever goes away, you got 10009. Getting rid of the first 2 numbers, and I'm left with 009. All right, so on the converting or encoding, oh, it's okay. We encoded, now we're decoding. So I'm giving the last 3 numbers, remember? So what I'm going to write is the 040. And I'm going to put a decimal between these 2 spots. So I know it's 04.0. Now I'm looking at this number. Is it above 5 or below? If it's below, you add a 10. If it's above, you add a 9. So these poor ones below the 5, they just want to be bigger and badder than the next. So they get the big number, 10. So this is going to be 10, 04.0. This next one, again, I'm putting a decimal between these 2 spots. Then I'm looking at this. This is a 1. It's less than, so I got to add a 10 in front. So it's going to be 10, 12.0. All right, let's look at the next one. Again, put a decimal. It's lower than 5, so 1006.4. All right, let's look at this next one. Putting a decimal right here, but this is above 5. So I got to put a 9 in front. So it's going to be 968.4. 823. I'm going to put a decimal right here, and I'm going to put a 9 in front. So it's going to be 982.3. Next one. Point right there. It's below 5, so 1032.1. This was again lower than 5, so it's going to be 1021. Put my decimal in between the last 2 numbers, 0.7. This one's higher, so it's going to be 972.3. It's less than, so I got to put a 10 in front, so 1005.8. Finally, less than 1016.4. All right, so you are going to be doing for your activity something very similar to this. If you have questions, please don't hesitate to ask me. Read the directions. If you have questions, hop on Zoom. I'm here 9:30 to 10 and 1 to 2. Hope you guys have a great day and a great Thanksgiving.